was able to do is measure that boundary layer between the sediment and the water interface, and what they found was a rapid decrease in dissolved oxygen. So even if we say, oh yeah, great, this habitat has 10 milligrams per liter of dissolved oxygen, it's really that boundary layer that we care about. Think from the perspective of the egg, not of the device that we're using. So that's a super hard measurement to get, and I haven't figured out how to get that yet. So we'll start there. So how do we test these mechanisms in a controlled environment? And that's where Tunison's wet lab comes into play. We do a lot of the stuff in the field, but we can also bring it back to our lab and control things. So I'm going to present 2 pilot studies today. These just got wrapped up 2 weeks ago, so everything's preliminary, but it gives you an idea of what we're measuring. So the first objective was to determine if there's mechanical shock source mortality for eggs. If you move Cisco eggs around, they die. Pretty simple. Second, if you add substrates that have large interstitial spaces and you have that same mechanical stresses, do you see more or less mortality? And then finally, we measured survival of incubating Cisco embryos across degraded habitat types. All of these were done in the lab. So, brief background on what we did for methods. We built experimental wave tanks, and we used these to simulate a storm event, which we'd see in Lake Ontario. So we subjected embryos to only 1 hour simulated storm events. As we know, storm events can take days in Lake Ontario and the Great Lakes, so this was just a short burst of energy. We had collected eggs from wild brood in Lake Ontario from Chameau Bay, so we just had a 1-to-1 male to female pairing to get rid of any genetic effects that I can understand at least. We had 3 treatment substrates, so sand, rock, and no sediment, and those were proxies for low, high, and no interstitial spaces. And then we had a control where we moved eggs from incubators into these wave tanks without turning the wave tank on, so didn't have any movement at all. We tested this at 3 developmental stages, which have been identified as big ones before pre-IF. So this is day 5, 8, and 12 after the initial fertilization. And then once we took the eggs out of these wave tanks after the hour of motion, we let them incubate for 2 days before we measured survival to see how many of those eggs had died in the wave tank. This is some imagery of what they look like before we used them, so just setting up in the lab. We had no interstices, so there's no sediment at all. We have low interstices, which is sand, and then high interstices, which is a cobble. Unfortunately, as soon as we turned these things on, we buried all of the Cisco eggs, so we weren't able to use those. Cisco eggs are about 2 millimeters, 2.5 millimeters, so it's kind of hard to work with these things, especially when you have bad eyesight, you can't see them. Okay, so to some preliminary results, on the x-axis here we have days post-fertilization, so this is those 3 developmental stages, day 5, 8, and 12, each one of those steps. Y is percent survival, and then the colors are the different treatments. So the control, where those eggs were moved to the wave tank, but the wave tank wasn't moved, it wasn't turned on, are high interstices, which is rock, and low interstices, which didn't have anything in the tank at all. And really the takeaway here, even though I'm going to talk about interaction in a second, is that rocks, in these environments where you have higher interstices, it increases on average across these different developmental stages, your survival. With the exception of this interaction that happened here where it looked like there was a bottleneck in development. So like I said, these are 3 important developmental stages. At day 8 seems to be a very important one, because even if you move eggs from an incubation tray into a wave tank, it reduces survival. And there was no motion in those tanks at all. So this wasn't significant between the high and low interstices at this point, but we saw reductions in survival across day 8 across the board there. Interstitial spaces created protective areas. Eggs adhere to the bottom and sides of the rocks. That's what we expected, right? So these are adhesive eggs. In these wave tanks that had rocks, when we removed the rocks from the tank, they were stuck to the bottom and the side. So it really shows you how important that adhesiveness is. So if you remove that with silts, then you might have some problems for survival. This is what those eggs look like that were not protected by interstitial spaces. So even within the rocks treatments themselves, there were areas that didn't have great coverage, like here, right? There's no protective area for the wave to hit the eggs, so you get broken chorions. And that's what we see in the wild a lot. So when we collect these eggs from Chameau Bay or other embayments in Lake Ontario, we see a lot of these ruptured eggs. Moving on to more of the chemical stressors, right? So we used incubation, static cube containers to incubate across these degraded types of sediment. So we used silt, which has high organic carbons, and we used dracenid hash, that's broken up hash, and then just a control that had no sediments at all. And those were incubated in 3 different incubation chambers, one at 3 degrees Celsius, one at 1, and one at 0.5 degrees Celsius. Those are to match the wild environment. We fertilized those, we incubated those from fertilization all the way to IUP before we pulled and measured survival. We also measured dissolved oxygen and temperature throughout the experiment, and we did this to be able to track to see if, because these are static, they don't have any aeration in them, if we were actually reducing dissolved oxygen. The nice thing about these super cold temperatures is when that water chills down, it can hold a lot of oxygen, so you don't necessarily get issues with DO, except for at the boundary layer, which we'll find out. So just a close up of what those look like. These cube containers, different sediment types, eggs were incubated in those. We have replicates for everything from the wave tanks and from these. I just didn't want to go into that. So again, preliminary results on that middle one's kind of hard to see, but on the x-axis you have the substrate type at each one of those columns. On the y, again, is percent survival. The colors are the substrates. So when we looked across different temperatures from 3 to 0.5, there was really no difference at all. There wasn't a significant difference. But when we looked across substrate types, there was a significant difference from our controls down to our silts. And then our quagga hash actually had 0 survival. Out of all of our replicates and all of our treatments, not a single egg survived to IUP. So what happened there? And this is what happened there. So when we looked at dissolved oxygen across that time period, that very top one is the coldest, so 0.5 degrees Celsius. The next one down is 1 degree Celsius, and this one that rapidly drops is 3 degrees Celsius. So we know that there was some type of anaerobic respiration going on there because it dropped dissolved oxygen significantly. And even more evidence is that once we mixed that water column and removed some of the eggs, it dropped down the DO even more in the same day, meaning that you had anoxic sublayer, and when you mixed it with the water that had more DO in the water column, it dropped down the full water column concentrations. So we had an anoxic layer in that sediment treatment. This is what egg development looked like from fertilization to IUP in one of our treatments. So our control, right, everything looks great. You have full development to IUP. In our silt, like I was talking about earlier with a lint roller, this is exactly what happens. These eggs get coated in silts. This one had success in development though, so it was able to get to IUP. And this is what every single one of our eggs looked like in Muscle Hatch. They had some amount of development, but they never got to IUP because they basically suffocated. So to conclude this 45-minute presentation, that's what's taking 15 minutes. Degraded habitats likely have an effect on embryonic survival, right? These are laboratory studies that need to be tested and paired with our